Okay, this is section 5.5, and this is number 43. And again, we want to get these equal to 0 first of all. So we can try to solve it as a, use the factoring method. So we have 2 sine squared of x minus the sine of x minus 3 equals 0. And then we know it's a quadratic, and again, we'll try to use a z substitution. That's a little bit easier for us to deal with. So we'll say let z equal the sine of x, and z squared would equal sine squared of x. Try to keep my colors consistent here. The sine of x squared of x. Okay, so my z equation, which is the equivalent equation, is just without the signs, makes it a little bit easier for you all to see. This could be 2z squared minus z minus 3 equals 0. And that's a lot. That's an easier general trinomial, because we know there's only one way to get 2z squared, 2z times z. Now we got 1 and 3 to get 3, so we have to kind of noodle this out. You could try some. You got some trial and error, but it's not too bad. You want to get negative, so you want a difference. If I put a 3 over here and a 1 over there, I'm going to have 6 times 3 minus 1. That's going to not work. So if I put the 3 over here and the 1, I'm going to have a difference of 1, which is what I have here. So we want these to multiply to give a difference of 1. Now if you multiply those and try them, you'll see what's going on. So if I put the 3 over here, I'd have 6, and I'd have 1. That's different. Going to be different by 5. But if I put it like this, I've got 2 times 1 is 2, 3 times 1 is 3, so 2 and 3 differ by 1, so I'm okay there. I want the larger to be negative, so 3 times z is going to be negative, so it's going to be negative and positive. Now we do have that other method that I've showed you before, where you can multiply the first term times the third term and redo it. But when they're both prime numbers like this, and you only have about 4 possibilities, you can pretty much get them pretty fast. So you need to acquire those process skills. So this is a good chance to do that. So now if we set each of these equal to 0, 2z minus 3 equals 0, and that means that z equals 3 over 2. And z plus 1 equals 0, so z equals negative 1. Okay? Then we go back and we just substitute over here. Sine of x is z, that equals 3 over 2. And the sine of x, or I should say the sine of x equals negative 1. Well, let's go back and look at the graph I did over here for the sine of x. And remember, we're still in that domain. And this was the sine of x. And notice how the sine of x over here is always between 1 and negative 1. All right? So the first part, this can't be because it can't be bigger than 1, and that's 3/2. And when is the sine of x equal to negative 1? Well, I go back and use my graph again. That's a nice thing once you draw the graph, you only use it once. And the sine of x is equal to negative 1 right over here, which is 3 pi over 2. So that's your only solution on that one. So that wasn't too bad. Okay, 45. Sine squared of x minus 1 equals 0. Now there's a couple ways to do this. We could factor it, or we could just add 1 to both sides. You can do that. So you could say that the sine squared of x equals 1. And then we could just take the square root of both sides, and we would get the sine of x equals plus or minus 1. Now if you factored it, it would be the same thing. So, and set each factor equal to 0. This is a little quicker way, so we could say the sine of x equals 1, or the sine of x equals negative 1. And again, we'll get out our sine graph again, which I already did. You could do it, over if you want. And it equals 1 at 3 pi, pi over 2. This is pi over 2, by the way. And this is 3 pi over 2. That's where it's negative 1. So this would be x equals pi over 2 and x equals 3 pi over 2. So that's what you got there. So that was a little bit easier, wasn't it? Okay. 47. Maybe I can get 47 over here. Here's 47. Separate this a little bit here. Okay, so there's 47, and 47 was 4 cosine square root of x minus 1 equals 0. Well, that's not too bad. Again, I could just isolate the cosine squared, so I've got the cosine square root of x. 4 times that equals 1. Divide both sides by 4, so I get the cosine square root of x equals 1/4. Then I just take the square root of both sides, so the cosine of x equals plus or minus the square root of 1/4. Now you might think that that's something weird, but it's not, because we could just say that the cosine of x equals plus or minus, and the square root of 1 over the square root of 4, which is plus or minus, what's the square root of 1? 1. What's the square root of 4? 2. 1/2. So the cosine of x either equals negative or positive 1/2, or the cosine of x equals negative 1/2. All right. Well, the cosine of x equals 1/2 when x is pi over 3. All right. So x will equal 1/2 pi over 3. And in the fourth quadrant, which is 5 pi over 3, and x equals cosine of x equals negative 1/2 when it's in the second and the third quadrant. So that's going to be 2 pi over 3, and x equals 2 pi over 3, and 4 pi over 3. Okay, so 2 pi over 3 and 4 pi over 3. So basically it covers, the pi over 3s. Okay, hope that's legible. That's not very good. 2 pi over 3, okay? And 4 pi over 3. So we got pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. This covers all your pi over 3s. Okay? That's not too bad. Those are a little shorter because we don't have to use a z substitution. Okay? Hope those help.